This video is to help you complete the experiment on lenses. In the first part we will be looking at the lens. I've already mounted this on the base, but I will go over that. But in the first part we have to determine the type of curvature of the lens we have. What I recommend is that you use a ruler, a flat surface, and look at the gaps between the surface of the lens and the flat surface, which is the end of the rule, and also look at the other side. The next step is to make our optical bench. The optical bench consists of 4 components. The first being a base, and the base is 20 inches by 5 inches. I accidentally cut the corner of mine, but that is not required. The next thing to make is the screen. The screen is 5 inches by 5 inches, and the base here is 5 inches by 2, and there's a little angle there to make sure that the screen is perpendicular to the base. The next thing we do is to use hot glue to mount our magnifying glass so that it is perpendicular to the base, which is 5 by 2 inches, and mark a line that aligns with the center of the lens. Lastly, we make our light source by using a 3" by 3" square of foam board and use clay to attach our flashlight. The height of the flashlight must be such that the flashlight will align with the center of the magnifying glass. Lastly, cut an arrow out of some masking tape and stick that onto the lens of the flashlight so that the arrow points vertically upwards. For the next part, find a darkened room with a window, and with a window with a view with an object in the distance. You may not be able to see it in the camera, but there's a mountain in the distance there. And I'm going to focus my arrangement onto those mountains. I have attached my magnifying glass using masking tape to the front of my base, and I've put the screen on there so it can be moved back and forth. I will now try and focus it so that I produce a focused image of a distant object on my screen. So I'll try and zoom in on the focused image. There we go. There's the focused image. So we built a simple camera. Once you have achieved focus, measure the distance between the center of the lens and the front of the screen. That distance is approximately the focal length of the lens. For the next part of the experiment, it's helpful to attach a post-it note to extend the base of the flashlight so that you know, trying to show it here, this front edge of the post-it note aligns with the front of the lens. Put your light source at the 0 end of the scale and arrange it so that it will hit the center of the magnifying glass. Put the magnifying glass so that the centerline mark of the magnifying glass is against the scale. Next, we're going to take our screen and place it somewhere on our yardstick that we put on the floor. We'll switch on a lamp and we'll adjust the distances until we get a focused image of the arrow on the screen. Adjust the distances until you get a sharply focused image of the arrow on the screen. We will see that the focused image is inverted, i.e. upside down, compared to the position of the arrow on the light source. Once you have achieved focus, measure the distance between the front of the flashlight, the center of the lens, and also from the center of the lens to the front of the screen. Try and find 3 different positions where a focus condition is achieved. And that's the end of the experiment.